Hello, welcome to inverse trig functions. Hopefully you have turned to this page in your notes and you are ready to get started on some inverse trig. All right, let's think about what does the word inverse mean? Where have we heard it before? What are some examples of inverse functions, or what I like to call operations? Well, up until this point, you've learned to solve equations because addition and subtraction are inverse operations, just as multiplication and division are inverse operations, just as anytime you're squaring something versus square rooting, those are inverses as well. And inverses take place because they undo each other. All right, so let's start off by drawing ourselves a triangle. We've got triangle CDE, where E is the right angle. And the tangent of C is 4/3. So let's think about what do we know about tangent. Tangent is the TOA. So this is telling me that the 4/3 is opposite over adjacent. All right, and I want to find the measure of angle C. So from looking at C, I know my opposite has to be the 4, because this is my center of focus, and then my adjacent would be 3. So how do I solve for C? Well, we can't yet. Until today, we are going to be talking about inverse trig functions that allow you to solve for angle measures. So up until this point, we've talked about SOHCAHTOA. So this is your classic opposite over hypotenuse and so on and so forth. So what we can do is we can use these operations and these inverse functions to solve for the angle. So if I want to solve for the angle of A, what I would do is I take the inverse, which has this -1 notation. It's not actually a -1. It's not really an exponent. A lot of students think it's an exponent, and it's not. It is just the notation for an inverse, which can get kind of confusing, but someone decided it along the way, and we just gotta follow the rules, right? We don't make them, we just follow them sometimes. All right, so inverse cosine, adjacent over hypotenuse, and likewise, we've got inverse tan would be opposite over adjacent. So it follows right in line with your SOHCAHTOA. All right, calculator practice. Get your calculators out and ready. If I want to get A by itself, I have to undo this tangent. And by undoing the tangent, what I'm doing is I'm taking the inverse. I can take the inverse of both sides, right? What I do to one side, I gotta do to the other. So I can take the inverse tan of this angle right here. All right, so when you get your calculators, I know yours is gonna look different than mine because you're probably using just a scientific, but in order to use these inverse functions, you have to hit the second button. So there should be a different color second button, and then I'm gonna hit inverse tan over here in blue. Do you see that? So I've got inverse tan of 0.75. And that is telling me that my angle is now 36.9 degrees. It didn't tell us how to round, so we're just going to go to the nearest tenth. All right, let's look at the next one. I undo sine by taking the inverse of it. So what I do to one side, I got to do to the other. So I go back to my calculator, second, and then I'm going to hit the sine button, and that blue option is going to give me the inverse, 0.87, and I'm looking at a 60.5. All right, good. Last but not least, inverse cosine. All right, second, inverse cosine, and I'm gonna do 0.15, which is giving me 0.4, I guess, if you round. All right, so you're gonna need those buttons later on today, so make sure you got those nailed down. All right, if you are finding a side, this is what we talked about earlier this week. If you are trying to find a side, you are going to use your regular SOHCAHTOA. If you're trying to find an angle, you need to use your inverses. So I got inverse sine, inverse cosine, and inverse tangent. All right, we're looking for a missing angle, so right away I know I'm going to have to use these at some point. Okay, so let's look at our angle. I've got, in relation to this, I've got 6, which is an opposite, and 11, which is an adjacent. So what am I given? Opposite, adjacent, that means I have to use tan. So I'm going to put tangent of x, because I don't know what x is yet. Opposite is 6 over adjacent. Now, how do I get the x by itself? I have to undo the tangent, and I undo the tangent by taking the inverse. So these cancel out, and that's why that works. All right, so I'm going to do inverse tan of 6 over 11. And I've got 28.6. All right, so there's letter A, I suppose. All right, let's look at this one. 11 is directly opposite. 38 is adjacent once again. All right, so let's give it a try. Opposite, adjacent, that's the TOA again. 11 over 38. And then I've got to undo it by taking the inverse tan. Punch that in my calculator. And I have a 16.1. All right, so now might be a really good time to go ahead and hit pause, and you can try example C on your own and then come back to check your answer. All right, let's see what you got. So the 45 is adjacent. 57 is hypotenuse, so I've got to use cosine. So cosine of x equals adjacent over hypotenuse. Got to take the inverse. 45 over 57. Put that in my calculator. I'm looking at 37.9. All right, let's move on to the next page. Now this is going to give us some mixed practice. You want to watch very, very carefully. If you're solving for a side, you use the regular trig, right? If you're solving for an angle, which we just learned today, you've got to use inverse trig, okay? So right off the bat, I'm looking at an angle. So this is going to be opposite. This is my adjacent side. So that is the tangent. Opposite over adjacent. Inverse tan. Put it in my calculator. 21.8. All right, next one. Now, look, I'm solving for a side. So if I'm solving for a side, I just use the regular SOHCAHTOA that we learned earlier in this week. Okay? So I've got to stay focused on this 40 right here. Remember, you got to put something in order to get something out. So I am taking, let's look, 17 is the hypotenuse, x is my opposite, so this is sine. So I'm taking the sine of 40 this time, and this is going to be opposite over hypotenuse. So again, this is a mixed review because this is the stuff that we saw on block day, and it was on your formative assessment. So we're kind of throwing both at you, keep you on your toes. Okay, so x equals 10.9. All right, so now would be an excellent time to go ahead and hit pause because you need to try example C and D on your own and then come back to check your work. All right, let's see what we got. Okay, again, I'm staying focused on this angle right here, 21. X is my hypotenuse. 11 is adjacent. So this is cosine. Cosine of 21, adjacent over hypotenuse. Then I've got to solve for x and put it in my calculator. Cosine of 21. All right, I'm looking at 11.78 or 11.8, I suppose. All right, next one, I'm looking for an angle. So again, I'm thinking, okay, I'm going to have to use inverse at some point. So this is my hypotenuse. This is my adjacent. This is going to be another cosine example. Cosine of angle is adjacent over hypotenuse. Take the inverse. .6 degrees. Now notice I am putting degree symbols when it's an angle and I am not when it's a side. So that's a very subtle detail, but it's an important one because a degree symbol is a big difference between an angle and a side length. All right, let's try a word problem. At a location 50 feet from the base of a tree, the angle to the top is 43. Determine the height of the tree to the nearest foot. All right, so we are looking for this height right here. All right, so let's think about this in terms of our SOHCAHTOA. The height is going to be our opposite side, and 50 is the adjacent side. So this is a tangent example. So I'm going to take the tangent of 43, which is opposite over adjacent, multiply by 50. So the height of our tree is 46. We got to round to the nearest foot, or should be 47 feet because we do want to follow directions. So always be mindful of that, especially on this test. I'm going to be very cautious about the directions on your test, which is a week from today. So be mindful of that. All right. So a 24-foot long ladder leans up against a building. Uh-oh, we don't have a picture, so we're going to have to draw one. I've got a 24-foot long ladder that leans up against a building. Try not to judge me too harshly on this ladder here. Okay, the ladder reaches 18 feet up the wall. What is the angle of elevation made by the ladder and the ground? Okay, so you want to think about the ladder and the ground. Where's the ground? Is the ground up here? No, the ground is down here. So you want to be coming from this angle. If you come from that angle, you're going to get the wrong answer. Okay, so in relationship, here's our opposite. 24 is our height. So this is sine. Is opposite over hypotenuse. All right, and we can solve by taking the inverse sine. All right, so we have 48.59, and it's asking us to the nearest degree. So we want 49 degrees. All right, that's a wrap, folks.